Hi. Today we're going over geometric sequences. Like arithmetic sequences, they're an important but sometimes confusing part of algebra, and they have pretty interesting properties. So we know standard sequences are just collections of values, right? But what makes a geometric sequence a geometric sequence? I'll start with an example. Say we have something like 16, 8, 4, 2, 1, 1/2, and that's that. And I look at this sequence and I wonder, is this an arithmetic sequence? And I quickly find out, no, it's not. The change from here to here is I'm subtracting 8, then I'm subtracting 4, and then I'm subtracting 2. What I'm subtracting by keeps changing. It's not constant. So I know this can't be an arithmetic sequence. And if I look at it carefully, I realize that for each value, I'm actually dividing by 2, right? And another way to say dividing by 2 is multiplying by 1/2, right? 16 times 1/2, 8. 8 times 1/2 is 4. 4 times 1/2 is 2. 2 times 1/2 is 1, and so on and so forth. What if this was, say, an infinite sequence, and I wanted to find, I don't know, the 10th or the 100th or the 1000th value of it? It'd be a pain in the neck to just write out all the terms. So there must be some convenient way to write this algebraically as like an equation or a formula that would make my process easier. Now we know we can write a formula for arithmetic sequences, but this isn't an arithmetic sequence. So we can't use the arithmetic sequence formula. We're going to have to find out a completely different formula. But just like arithmetic sequences, I'm going to represent, a given term, right, as a to the n, where n is the number of that term, right? So a to the 5 represents the fifth term in the sequence. Let's actually start it with a to the 5, because I know something pretty interesting. For the fifth term, I'm multiplying by 1/2 4 times. I do it when I'm going from 16 to 8, and when I'm going from 8 to 4, then 4 to 2, then 2 to 1. So as part of that whole process, I multiply 1/2 by itself 4 times, or I raise it to the 4th power. For the fifth term and the 4th, that's an interesting relationship. I could almost say, if I was a to the n, then I'm going to take what I guess is my common rate, my common ratio. I can represent that as r. Doing r to the n minus 1. But that's not all. Because if I just do that, I'll get 1 over 16, which is not what I get. Then I realize, okay, we're doing all that to the first term, right? We get 1 because we're doing 16 times 1/2 times 1/2 times 1/2 times 1/2. If we were to write all out what we were doing, if we were to combine all this, if we did this, we would get 1. If we say, hey, 16 is the first term, that first term property that I saw in arithmetic sequences must also hold true. So a to the n is equal to a to the 1, the first term, times my common rate, my common ratio, raised to the n minus 1 power. So if I'm looking for the fifth term, I do my common ratio, which is 1/2, I figured that out, to the 4. Let's say I wanted to use all that to find the 10th power, right? What's a to the 10? Well, that's I know my a to the 1 is 16, and my common rate is 1/2, and then 10 minus 1 is 9. So I have 16 times 1/2 to the 9. And this still is a little hard, but it's certainly a whole lot easier than manually going out and doing all this math. So I get 16 over 5/12, which of course, if I simplify further, I get 1 over 32, which is my final answer. That is the 10th term in this sequence. And this once again, is the kind of interesting part of geometric sequences. We can represent something that is, practically infinite. There are infinite number of terms in this sequence. We can find every single term by using just a simple formula, right? And if you wanted to find this common ratio, this is a lot easier than finding the given term that you're looking for. You just look by what ratio, by what proportion are each of these values being changed by. In this case, we could say, hey, they're each decreasing, they're each being cut in half, right? So my ratio is going to be 1/2. So if I multiply them, each of these terms by 1/2, I will get the next term. So that's how I know that's my common ratio, or my common rate. And that is geometric sequences. I hope that helps you, and I hope you have a great day.